So let's take a moment to think about eliciting student thinking. So basically, when we elicit student thinking, this means that we're going to pose questions to students to better understand their thinking. So you might imagine yourself in a classroom, and you might imagine a student sitting down and doing mathematics. And basically, this is what you do when you approach them. What do you do next? What questions do you ask? Well, I always open up with a question that says, tell me what you're thinking. That's a great way to start eliciting a child's thinking. And by doing that, you're getting the child to share with you their thinking or their understandings about the task, okay? So when you're asking that question, you're uncovering mathematical understandings. Interestingly, even if the child's answer is incorrect, when you ask them to share their thinking, you're actually going to uncover some mathematical understandings, even when students' thinking is incorrect. Because even within their explanations, as you ask follow-up questions, you're going to understand what they do understand about the mathematics, as you're also uncovering some misconceptions. And then these ideas that you gather through eliciting their thinking, posing these questions, are going to be used to guide your instructional decisions. That means to decide what you're going to do next with this student and with this small group and with the class. So basically, as you're posing these questions to elicit their thinking, this is a form of formative assessment. Formative assessment informs our instruction. So by posing these questions, it's going to help us know what to do next with kids. I want to provide you with some tips for eliciting student thinking this week as you got started. So these are things to avoid and things to do as you approach students and start posing those questions to understand their mathematical thinking. Because we as teachers, we became teachers to want to help, right? So it's really easy for us to ask leading questions or to actually do the mathematics or do the mathematical thinking for kids. And we're trying to help, but really we're taking away their mathematical thinking. For example, you might approach a child who's working to solve a problem, and you might be thinking of this problem as a subtraction problem. You're thinking, oh, they need to subtract. And so you might say, should you have added? Right? And you're trying to be helpful, right? You're trying to get them to use the right operation. But by basically leading them to that operation, you're actually taking away the thinking for them, right? And you're doing the mathematics for them. Because really the hard part about solving a word problem is determining how to go about doing it, right? Making sense of it and how you're going to solve it. So if we take that away from kids, we're really taking away the mathematics of actually doing mathematics. Also, it's not your job as a teacher to tell kids that their answers are correct. It's their job to convince you. So position yourself in a way that your students have to convince you that their answer is correct, as opposed to you being the one to tell them if it's correct. Because if they can justify their thinking using pictures or drawings or words, then really they don't need you to say the answer is correct because they have already convinced themselves, right, that the answer is correct. So don't make it your job to tell them it's correct. So even when students are correct, right, and they're able to explain their thinking and they've met your learning goal for a particular task, your job as a teacher is not done, okay? It's not like, oh, they've got it, now I'll just move them on to something else. What you want to do is to pose questions then that are going to extend their thinking. You might think, I'm going to pose questions to make them even smarter. So they've done this, but now what can I say? What can I give them to do? What kind of questions can I pose to make them think even more about this topic we're focusing on? So you might say something like, could you share your thinking in a different way? Or you might get them to connect their solution strategy with a peer's strategy for solving the problem and see how they're connected. You might ask them to convince someone in writing how to solve the problem because you want them to focus on their mathematical communication and using appropriate vocabulary. So those are things you might do to extend their thinking. You might think about that as making them even smarter, all right? Some things I sometimes see in classrooms that aren't great for extending student thinking is basically when you make a brain shift, right? And you just say, oh, you did great. Why don't you go over to the computer station and work on that for a while? Okay, that's not going to extend their thinking on the mathematical goal of your lesson, okay? That's almost like just babysitting them while the other kids are still solving, right? So we want to make sure that their minds stay engaged in the task. Another thing that teachers often do, and they have the best of intentions, is they'll say, why don't you now go and help your friend solve this problem? Well, when you send one child over to help another child solve the problem, what usually happens is the more confident child, the child who has the correct answer, is going to walk over and say, you're supposed to subtract. Here's how you do it. Write this down. So basically, that child has also taken away the thinking opportunity from the other student that you've sent them to help. So I hope that this quick video has helped you jumpstart your thinking on what it means to elicit student thinking and has provided you with some tips as you move forward. This week, you should be becoming even better at posing questions than you were last week.